Welcome to Greg's Docker demonstration, where we'll look at a basic Docker example and using Docker Hub and creating a Spring Boot application and Dockerizing it, pushing it to Docker Hub and downloading and installing it on Openshift. Okay, so first of all, let's look at Docker Hub. So Docker Hub is the public repository. You've heard of GitHub. This is Docker Hub. It's the public repository used for sharing Docker images. If you're in a corporate environment, you'll have a corporate repository for your Docker images. So we can look at just have a quick browse of the public repository. You can see we've got Nginx load balancers, we've got Ubuntu machines, we've got databases, etc., etc. We can search the Docker repository. So the example that I want to look for is fabric8 /java/alpine, and we'll see why I want to do that in a moment. So that's the JDK8 one. I can copy the pull command. I can go to my machine where I've got Docker installed, and I can cut and paste that command in there, and I can download the image from Docker Hub and install it in my own local Docker repository on my machine. And there we are, it's downloaded. Let's look at what we've got then. So we can go to Docker, and we've got Z shell, so you can tab and it will guess. If we look at Docker images, you'll see that the only Docker image I've got in my local Docker repository is the one that I've just pulled, the one that I've just downloaded. Let's run that Docker image with a Docker run -interactive -terminal entry point bin sh, and the Docker image that I'm running is fabric8 latest. That's loaded the image in a Docker container. So a Docker container is a running Docker image. You can have lots of images in your repository. They don't all need to be running. Let's have a little explore, and you'll see that this is looks like a Linux machine. It's got Linux Ubuntu 64-bit installed upon it. If we have a look at the operating system, for those of you familiar with JBoss, it looks very much like a JBoss environment. Got a deployments directory. We can look at that, and you'll see that you've got some shell scripts there ready to run Java if you need to. I assume that it's got a version of Java on it, and it's got JDK8 64-bit Java installed. Let's log out of that Docker image, and we can see that that Docker image is a Ubuntu 64-bit. It's like having an Ubuntu 64-bit machine. The image is saved, put in our Docker repository, and we can run it up when we want to. So let's just remember that for the moment, and let's look at our Spring Boot application now. So I have downloaded the sample Spring Boot application, Hello World Spring Boot application. We can just quickly look at that application. Standard Maven project. We can look at the application file, and you'll see why can't I do that? So I did it twice. So you'll see that we've got a Hello World Spring Boot application, and we've got a little message that it's going to print to the screen. I can build that in a usual Maven way, Maven clean install, and it will run the Maven file, it will run some tests and build the Uber jar that Spring Boot uses. I can now run that Spring Boot application using Java. That will fire up the embedded Tomcat in the Uber jar, and I can go to that in a browser, localhost 8080, and there's my Spring Boot application running. Let's stop that. Let's look at the POM file. So we've got a standard Spring Boot application. We've used a group ID of com .gregclinker. We'll come back to that in a moment. And we've got an artifact ID of boot docker. The plugins are important. We've got 3 plugins. The first one is just the Maven compiler plugin, nothing unusual there. Second one is the Spring Boot Maven plugin, which is the plugin that creates the Uber jar so that Spring Boot can run from Java. And finally, we've got this fabric8 plugin, which is the Docker plugin. This time, if we build it again, let's skip the tests just to make it go a little bit faster. And let's run the fabric8 plugin to build a Docker image. This will build the Docker image and install it in my own local repository. That finished successfully, so now I can do a Docker images command, and you'll see that I've got 2 more Docker images. I've got the original one that I downloaded to the fabric8 Java Alpine OpenJDK. I've also got this fabric8 Java Alpine JDK version 1.2, and I've got my own gregclinker boot Docker image. What the plugin has done is it's taken the fabric8 JDK, slightly different version from the one that I downloaded. It's taken that as a base image and it's built my boot Docker image on top of that. Let's run the Docker image that I've just built. Docker run -interactive -terminal. Let's log into it as a shell. And you'll see that this looks just like the previous Docker image we had, the Java Alpine JDK image, which is basically a JBoss Linux machine, except this time if we go to the deployments directory, you'll see that we've got the boot Docker jar, which is my Spring Boot application. Let's log out of there, and before we run it properly, let's just look at what the Fabric plugin created for us when we built it with Maven. If I look at the target directory, this is the build directory that Maven uses. If I look at the Docker directory, this is where the Docker plugin has done its work. You can see that we've got the boot Docker jar, which is the Spring Boot application, and we've got this Docker file. Now, with some Docker plugins, some Maven plugins that Dockerize applications, you specify the Docker file yourself. With this particular plugin, with the Fabric plugin, you don't need to do it. It will create it for you, which is really useful. So if we look at that Docker file, you'll see that it says where it's what the base image is, which was fabric8 Java Alpine JDK 1.2. We've got some environment variables set, and we're going to expose some ports, and then we're going to copy the contents of the Maven build directory into deployments. So we've got a machine ready there to run. Let's actually run the application up. We can do a Java, no, we can do a Docker run -interactive -terminal, and we can give it the. So this time we're not using an entry point of shell. We've left the entry point off, so it's using the default entry point, which is to run the application up. Let's go to it in a browser, and we can refresh that, and it couldn't be reached. And the reason it can't be reached is because we didn't expose any ports. Let's stop that, and this time let's specify some ports with the port command. So we want to expose 8080 from the virtual machine to the outside world at 8080. So we can run that again. This time it will expose the ports. Start it up, and we can refresh, and there is the Docker container running with the ports exposed to the outside world or outside of the virtual machine. Let's push it now to Docker Hub. So I've logged into the Docker Hub, and let's just have a look at the top of the POM file again. Now, I deliberately called my group ID com.gregclinker and my artifact ID is boot.docker. So by default, the plugin will take greg.gregclinker as my ID on Docker Hub to push the image to. So we can do a maven clean install, skip the tests, we want to build it, and we want to push it. So all of these commands that the plugin is running are just wrappers around standard Docker commands. We could have just pushed that Docker image straight from my local Docker repository to the public Docker Hub, and it's pushed. If we go to the Docker Hub now and we go to our home directory, you can see there's my image, my Docker image pushed to the hub, and we can look at the tag and you can see that it's version 1.33, 85 megabytes, and it was pushed a few seconds ago, so we know that's the one we just created. So that's Docker, and if you think about Kubernetes, when Kubernetes is running inside Maven, when Kubernetes is running inside Openshift, Kubernetes is just doing all these Docker commands to create an environment, to take images that it has in its repository, to run them up as pods. Let's go to Kubernetes. Let's go to an Openshift now, and let's install it. If I go to my work directory, and I've got an Openshift project, and my Openshift is running inside Vagrant, which is a VM. So Openshift is actually running itself inside a VM, and then it will run Docker inside that VM, which is another VM which will run images as containers to create an environment. If we go to the admin console for the Openshift that I've just started, password, default password, admin. This is an example that I created earlier, so we'll just delete that. And while it's thinking about deleting that, we'll create a new project. We'll call this project Docker2. Won't worry about display names for the sake of the demonstration. So this is our default page, all the different ways that we can deploy applications. We are using Docker images, so it's quite easy for us. We go straight to deploy image, and we are going to deploy the image from Docker.io. So it found the image on Docker Hub, and we can continue to the overview. It's trying to do something here, thinking about something, so we can look at the logs. If we look at the logs, you'll see that it is downloading the Docker image and it's trying to run Docker. So this is Kubernetes, which is the application that sits above, which is the manager for the Openshift environment that is running all these Docker commands that we've run manually in the demonstration previously to create an environment. If we go to overview, you'll see that we're running now. Pods are up okay. We need to create a route to get to the outside world. For the purposes of demonstration, we'll just accept all the defaults. That's created the route. If we go back to the overview now, if we go to this, let me just find it. There we are. Okay, so it went to the overview now, and we can run the application, boot Docker apps, and we've got the application running. And that concludes the demonstration. Thank you.